Hello everyone, myself Kalaichilvi, working as an assistant professor in the Department of Mechatronics Engineering for past 10 years. Today we will discuss the single phase induction motor, which are very common in everyday applications. Yeah. These motors are widely used in domestic appliances such as fans, pumps, washing machines, and refrigerators. So they are especially useful in places where three-phase power supply is not available. So the advantages of single-phase induction motors, which includes the simple construction, low cost, and then easy maintenance, reliable operations. So, however, an important limitation is that they are not self-starting function. So, special starting methods are required for this working. So, this is the main empathize of this single-phase induction motor. Here we are following the 5 stages of design thinking process: empathize, define, ideate, prototype, and then testing. Um, Here the basic construction of single phase induction motor in a defined part. So a single phase induction motor mainly consists of 4 important parts as like the DC motor, stator, rotor, air gap, and then bearings. Okay, so the stator is the stationary part of the motor, which consists of laminated steel core and stator windings. So rotor is usually a squirrel-cage rotor. It rotates due to electromagnetic interaction with the stator field. And then air gap is nothing but a small uniform air gap is maintained between the stator and rotor to allow a smooth rotations. So here bearings are also used for the support the staff. Like a bearing supports the shaft and reduce frictions during the rotation. This is the stator construction and windings. This stator contains 2 important windings. One is main winding, another one is auxiliary winding. So main winding is nothing but which is connected directly to the single phase AC supply, which carries the main current. So auxiliary winding is placed 90-degree electrically from the main winding. Uh, it is used mainly during the starting. The auxiliary winding helps produce a phase difference, which is necessary for starting torque. And then rotor construction, which is screw cage. So the rotor used in most single phase induction motor is the screw cage rotor. So this rotor core made up of laminated steel to reduce losses, and then rotor bars is aluminum or copper bars placed inside the rotor slots. End ring has the bars are short circuited at both end using end rings. So and then the shaft rotates and transmit the mechanical power to the load. This rotor construction is very simple and strong, and then maintenance free also. And it is the principles of operation. The working principle of a single phase induction motor is explained using a double revolving field theory. According to this theory, the alternating magnetic field produced by a single phase supply, which can be resolved into 2 rotating fields. One is forward rotating field, another one is backward rotating field. This forward rotating field rotates in clockwise direction at synchronous speed, and then the backward rotating field rotates in opposite direction with the same speed. So at stands and at standstill condition, forward torque is equivalent to the backward torque, and then net torque is equivalent to 0. Therefore the single phase induction motors are not self starting. So that's why we are using the starting methods. To start the motor, special starting techniques are used. First one is split space method. Second one is capacitor start method. Third one is capacitor run motor. Final one is shaded pole motor. Split phase method uses a auxiliary winding and centrifugal switch, which produces the moderate starting torque, and the capacitor is connected in series with the auxiliary winding is called capacitor start motor, which produces the large phase difference and high starting torque. A capacitor remains permanently connected in this circuit is called capacitor-run motor, which improves the efficiency and power factor. Shaded pole motor uses a shading coil around part of the pole. Simple construction but low starting torque. These are the types of single phase induction motor. Based on the starting method, these motors are classified into split phase capacitor start, capacitor run, capacitor start run, and then shaded pole motor. Each type is selected depending on torque requirement and then applications. So important performance characteristics, which includes the efficiency, power factor, speed regulation, starting torque. Efficiency is typically between 60% to 80%. The power factor is generally lagging, but it improves as load increases. Speed decreases slightly when load increases. Good speed regulation is maintained near synchronous speed. And then for the starting torque, which depends on the starting methods used. Capacitor start motors provides the highest starting torque. Speeder characteristics shows the relationship between the motor torque and speed. Here the forward torque is equivalent to backward torque or reverse torque. Net torque is equal to 0. We already shown in a previous slide. After starting, forward torque becomes dominant, and then motor accelerates towards the synchronous speed. I mean, this is the mind map of single phase induction motor. Here the single phase induction motors widely used in ceiling fans, water pumps, refrigerators, washing machines, small machine tools. These are the applications requires. These applications are requires the low power and simple operations. That's why we are choosing the single phase induction motor for their application. So here recap and summary. So let us summarize. The single phase induction motors are widely used in domestic applications. They have simple construction and low cost. Operation is based on the double revolving field theory, and they are not self-starting and require starting methods. Performance depends on the torque, speed characteristics and load. Thank you.